In this video, we'll go over everything you need to know to get started with the ECHO HC-10 Quick Lambda Thermal Conductivity Tester. The HC-10 is designed to measure the thermal conductivity of a wide range of homogeneous samples and vacuum insulation panels, also known as VIP, in just 60 seconds. We'll cover the important basics of calibration and measurement with the HC-10. For more details about operation, maintenance, and software, please refer to the HC-10 user manual, which can be found on the ECHO website. Here's everything that comes with the HC-10: the power adapter and cables, the main unit, the sensor head, and the checkup samples. The HC-10 is incredibly compact and portable and requires minimal setup. With the LCD display and the control panel, it can work with or without a laptop or PC. Because the HC-10 is a relative measurement device, before measuring a sample, we need to calibrate the device for that type of sample. You only need to do this once for each type of sample, as you can reuse the same calibration file for future measurements. First, let's set up the unit. Plug in the power and sensor cables and turn the power on. To calibrate the HC-10, you'll need to prepare 3 to 4 samples with known thermal conductivity values. Ideally, at least one sample with high, one with medium, and one with low thermal conductivity. When testing VIP, these would be samples with poor, medium, and excellent condition. The thermal conductivities have to be measured in advance using an absolute method, such as HFM or GHP. From the main menu, navigate to Calibration and select an empty calibration file. Here, for instance, we chose Cal004. At the top of the screen, you can switch the thermal conductivity unit between microwatt per meter Kelvin and watt per meter Kelvin. On the left side of the screen, you can see the lambda values, lambda 1 to lambda 4. These are the known values of your calibration samples. Start filling the values in order using the control pad. In this case, we know our samples are 0.03, 0.23, and 1.05 watt per meter Kelvin. You can see E1 to E4 on the right side of the screen, which are the voltage measurements attributed to lambda 1 through 4. We'll fill in those E values later by measuring the samples with the HC-10. At the bottom of the screen, you can also set thermal conductivity thresholds as V1 and V2, which will help quickly evaluate the quality of a sample during measurement. Once everything is filled out, press the Start button to begin calibration. Allow the sensor head to cool for 30 seconds. This will temper the sensor head for measurement. When the status changes to ready, place the sensor head on the first sample to measure E1, which relates to lambda 1, and press the Start button again. After 30 seconds, you'll see the E1 value, meaning you successfully measured the first calibration sample. Repeat this process for the rest of the samples to finish the calibration. During calibration, the HC-10 measures and calculates heat transfer. In this case, we have 3 samples, so we can see 3 plots and 3 E values being recorded. From the 3 recorded values, a calibration curve is then plotted. This curve will later be used to compare against during measurement to determine the thermal conductivity of your test samples. Note that the HC-10 comes with a pre-configured calibration file using the EPS, acrylic, and Tempex glass samples. These are used to check the condition of the sensor head. Up to 20 calibrations can be stored on the main unit, and when using the PC software, you can store even more. So, we've learned how to calibrate the HC-10, but how do we actually measure samples? To start measuring using the calibration file you made, select Measurement from the main menu and select the calibration file related to the samples you want to measure. This is the file you created during the calibration step. Then, with the sensor head in the cooling socket, press Start to begin the cooling process, just as we did when measuring those calibration samples. When the status changes to ready, place the sensor head on the sample and press Start again. After just 30 seconds, the results will be displayed and saved. Repeat by setting the sensor head in the cooling socket and follow the same procedure for all your samples. If you have set thermal conductivity threshold values during calibration, you'll see a qualitative assessment of the sample's measurement results classified A, B, or C to indicate poor, medium, and high quality. And that's everything you need to get started with the HC-10 Quick Lambda Thermal Conductivity Tester. Thanks for watching.